So in question 3, we want to sketch the graph of the function x squared minus 4 for the domain x greater than or equal to 0. So your graph is only going to be on this side here. So if you choose a few points, you can do this with me. So get your tablet out or your paper. So I know roughly what this looks like, but let's make a table of numbers. So x and y. And we don't care about the negative numbers. So let's just do 0, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So you put your 0 in here. So 0 squared minus 4 is minus 4. So 1 point is 0 minus 4 down here. And then 1 minus 4 minus 3. So 1 minus 3 here. 2 squared is 4. 4 minus 4 is 0. So that's going to be here. 2, so it's going to be 0. So 3 squared, 9. 9 minus 4 is 5. So 3 would come up to 5. So you can see you've got part of a quadratic, but you don't have this side. So let's do a couple more. 4, 16 minus 4 is 12. So I think we don't want to go any further. So 4, 12 is here. Okay, so you can probably do better than this. So draw a curve through them, and this will be your function here for the domain x greater than or equal to 0. So nothing on this side. Remember, this is your x-axis here. So I don't care about the graph on this side. So if you look at that, right? So can you do that? You should get a graph like that. So that's your graph. This is x squared. So this is x squared minus 4 and x greater than or equal to 0. So this is your domain and this is your function. Reflect the function in the line y equals x. So put y equals x in. You can use a different colored pen for that. I'll use black. So that's going to go up through here. It's easier for me to do it directly on the tablet than looking at the screen like that. And it will also go down, won't it? Like that. Okay, so this is y equals x. Like that. So it says reflect. So we could choose some points that we had. So this point here, remember, is 0 minus 4, right? Yeah, that's 0 minus 4. And on our inverse, that would be minus 4, 0, which is here. Okay. And then we're going to pass through this point here. So the graph is going to go this way. And what did we have here? We had 3, 5. So this was 3, 5. And 3, 5 becomes 5, 3 here. That's 5, 3. We had 4, 12 becomes 12, 4. 10, 11, 12, 4 here. So I think I want another one. 1 minus 3, minus 3, 1. So actually you just practice drawing the function and the inverse, that's it. And that will go on further like that. Okay, so this is your inverse function here, right? All we did was swap x and y like before. So this is your inverse function. Notice that they're both functions, aren't they? See this one here. Let's check this. I'll use a blue pen. So this is your function and it passes the horizontal test. So this passes the horizontal line test, because it only cuts one time everywhere, okay? It doesn't matter where you go, it will cut only once, okay? So if you pass this horizontal test on your function, you can say, therefore, fx has an inverse function. And indeed it does, because you see this one here is a function, has an inverse function. So if your function passes the horizontal test, it will have an inverse function. And we know that this is a function. Look at this, because it passes the vertical test. If you pass the horizontal test here, the horizontal test here becomes a vertical test here because X and Y swap. So therefore the test swaps as well. So if you pass your horizontal test here, you're going to pass your vertical test here. So and therefore f inverse X is a function. And we can tell it is, it's going to be 1-to-1. It's a function because we passed the vertical test. Okay. What else did we have to do there? Let's see. Here we need to get our function. We need to get this equation. You see, by looking at this, I think it's hard to tell what it is, isn't it? What's going to be the equation? So let's use our function here. So we'll write our function down, x squared minus 4. So let's come down. So fx equals x squared minus 4, and x is greater than or equal to 0. We don't need to use that when we calculate, but just keep it there. That applies to our red line here. This is the red one, function. So we just do like we did before. We write y equals x squared minus 4. And now we want to swap x and y because we're trying to find the inverse. So x equals y squared minus 4. So let's rearrange that equation. Y squared equals x plus 4. Now this is where we square root both sides. And don't forget plus or minus. So we have two possible answers. So y squared, well, y equals plus or minus root x plus 4. Okay, so, but your graph has only one part of that, this part here, which is on the positive side. Okay, so as x gets really large, if you put big number in here, you're going to have a positive y value, aren't you? It's not down here. Okay, so your answer then, your final answer is, for your inverse, is going to be root x plus 4. Okay, and x must be, so your new domain is here. So greater than or equal to minus 4. Minus 4. This is your new domain. So that's your answer there. That's going to be your final answer. And I put the domain in as well. So that is the plus side here, because you're up above the axis, okay? But if you're probably wondering, where is the negative one? The negative one is down here, which I didn't draw. It would be here, okay? That would be the negative side, but you don't need that. That would be for negative. But we only want the positive side, the bit that's up here. Because when x is really big, so if x is 15, you're going to get root 19. And obviously it's on the positive side, isn't it? So it's plus root 19. The other side would be minus root 19 down here. So there's actually another part to that graph, which is down here. So we have a positive side up here, and we have a negative side down here. Okay. So when you've drawn your graph, you can kind of work out whether it's plus or minus. in this one here.